So hey guys, welcome to my channel. Today GeeksforGeeks problem of the day is note at given distance in binary tree. Given a binary tree, a target node in binary tree and an integer value k, find all the nodes that are at distance k from the given tree node. No parent pointers are available. You have to return the list in sorted order. The tree may contain duplicate values. Okay, let's check the example. They are given a binary tree and the target node 8 and k equal to 2. So we have to find the nodes at distance 2 from 8. Okay, like from 8 the distance of 4 is 1, the distance is 12 is also 1, the distance of 10 from 8 is 1 2, and distance of 14 from 8 is 1 2. So we will take this 10 and 14. Also from distance from 8 the distance of 22 is 2, like from 8 to 20 is 1, from 20 to 22 is 2. So the output is 10, 14 and 22. Okay, now let's try to understand this problem and also try to solve this problem. Okay, we can easily do from this example we can easily do something. Okay, what, like if we find this 8, okay, if we found this 8 in our binary tree, we can check in its subtrees, right? Its subtrees, like there are any elements at distance 2 or not. Like if I target, like at target, if I consider the distance as 0, from its left child the distance is 1 and 1. From 8 we can further go its right child, the distance is 1, and from it 12 we can go 10 and 14 with distance 2, and if the distance is 2 we will add them to our answer, right? Like we will add 10 and 14 to our answer. We can easily compute this part, like each subtree. But from this example you can say maybe our answer can be present in its parent subtree, right? If our target is at the left subtree, then we have to find its parent's right subtree. Okay, like if we consider 4 as our target node, 4 has no subtree, right? It has no left subtree, it has no right subtree. So we have to check its parent subtree. So what its parent subtree? Like if 4 to 8 the distance is 1, 8 to 20 the distance is 2, so we consider 2 as our answer. 4 to 8 is distance is 1 and 8 subtree is what? 12. So we will consider 12 as our answer. From 12 the distance becomes more, like for 4 to 8, 8 to 12 and 12 to 10 the distance is what? 3. So we will not consider the greater distance. So we, after this, if our distance is increased by value of k, we will return. Okay, so what we can say from here? Okay, I find this 8. Now I have to check, is there element at distance 2 in each subtree? Okay, if they are present or not present, after that I have to go in its parent subtree. Now for 4 there is no subtree, so I have to look for its parent, and 4 is a left child, so I have to check its right child, like its parent right child. We can find a element of the distance or not. After that I have to go to its grandparent, like to 20, and check is this distance is satisfied or not, or I have to check its parent's node or not. So I will show you the code first, so you will understand it properly. Okay, now this is the code. Like now think, now we will find that node first. Okay, we will find that node. Now if we don't find that node, we will return -1. Now if we find that node, like node dot data is equal to target, we will check its subtrees. Okay, we will traverse in its subtrees and check if any element are present at distance k or not. Okay, let's check the code first. In subtree, like if node equal to null, okay, we will return what? We will just return if k value is less than 0, we will return. Okay, here what I did, I take this k value at 8 as 2. Okay, So if from 8 if I go to 4, the k value reduced by 1. Like you can say here, if I go to a left subtree, the k value is reduced by 1. If I go to right subtree, the k value is reduced by 1. So at 8 my k value is 2. If I go to 4, its value becomes 1. If I go to 12, its value becomes 1. From 4 I can't go anywhere. From 12 I can go 10. So from 12 when I am going to 10, my k value is at 12 my k value is what, 1. From 12 I am going to 10, so my k value is becomes 0. If my k value is 0, I will put this value to my answer. Okay, like 10, the k at 10 the k value is 0, I will put 10 at my answer. Okay, from 12 I can go further at 14. At 12 my k value is 1. At 14 it becomes k minus 1, that is 0. If it is 0, we will put this node to my answer. Okay, this part is for the subtrees. Okay, now after checking at subtrees, I will check. Now if we start traverse through 20, like from 20 we can go its left child. Now I will find this target and now return 0. So the left, so it the 0 return to which node? This 0 returns to the node 20. So the left value of this node become what? 0. That left is less than equal to 1. No, what that means? Left is not equal to minus 1. What it means that we will find a node. If we don't find a node, we will return minus 1. Otherwise we will return 0, which actually return the left value is now what? 0. It's not equal to minus 1 because we will already find this node. So what it means, if k is equal to 1 plus left, that is left is 0, 0 plus 1 is what? 1, and my k value is what? 2. So it's not. So we will go to the else part. What we did in this else part, we will find its subtrees, its parent subtree. Like this 8 is a left child, we find 8 at the left subtree of 20. So now we have to find what in the right subtree of this node. So we find at the right subtree of this node, like if there is any element at distance k or not. We will reduce the value of k, like at target 8 the k value is 2. When I am going to this parent, the k value is reduced by 1, and if I try to find in subtree, the k value is also reduced by 1. So we will like k minus l minus 2. As well as if I find this node at right subtree, we will, so same like that, if we find that node at right subtree, we will check if we have to consider if the parent is in less than range, then we have to find its parent subtree. Okay, and then we'll return this right pointer plus 1. If we can't find these things, so we'll return minus 1. Now we make a answer array list, and we will find, and we'll call this function find node, and after that we will sort our answer and return the answer. Let's compile this. Okay, it's working fine. Let's submit that code. Yeah, so thank you all. That's all for today.